Hello everyone, welcome to this session on synthesis of mechanism. In today's session, we will be discussing about the pole method of synthesizing a mechanism. So let us first understand what is meant by a pole. So a pole is defined as a point with respect to which a link can be guided from one position to another by a simple rotation about that point. Let us understand this definition through a diagram. So let us say we have a link BC that is lying into two positions. One is B1C1, another is B2C2. Let us say we want to move the link BC from position B1C1 to B2C2. So there could be two approaches to do that. One is to move this link from point B1 to point B2, right? That means you simply translate this somewhere here and then you give a simple rotation about this point B2 to acquire this new position B2C2. Another approach is you rotate the link BC about this point B1 first, right? And make it parallel to this new position B2C2. And then what you do, you simply translate this link from position B1 to position B2. So you can see that the link BC, it can be moved from one position to another position by a combination of translation and rotation. However, if we locate or define a point P12, right, so that this link B1C1, it can acquire this new position B2C2 by a simple rotation about this point P12, then this point P12 is called as a pole point. Now let us understand how can we obtain this pole point P12 for the rigid body BC or for the link BC. So we will understand this thing through a simple construction. So first what we are going to do, we are simply going to join point B1 and point B2 through a dotted line. Similarly, we will join this point C1 and C2 through a dotted line. So you can see this is the first line and this is the second line for joining these points B1, B2 and C1, C2. Now after joining, you simply draw the perpendicular bisectors of B1, B2 and C1, C2. So this line, this is the perpendicular bisector of this line B1, B2, and this line, it is the perpendicular bisector of C1, C2. Now these two perpendicular bisectors, they are going to intersect at this point P12. So this point P12 is the required pole point. So this is how you can obtain the pole point for a link moving in a particular plane by simple construction.
Now let us visualize the pole point in context to a 4-bar mechanism. Now to understand this, let us consider the 4-bar mechanism as shown in the diagram. Now here, if you consider the perpendicular bisectors of B1, B2 and C1, C2, right, what we are going to do, we are simply going to assume any 2 points A and D on these perpendicular bisectors. Now these 2 points, they can be located arbitrarily at any position on these two perpendicular bisectors. Now simply join this point A, right, with B1 and similarly this point A with B2. Now in the same fashion, you join this point D with C1 and C2. Now this whole situation, it can be imagined that this 4-bar mechanism A, B1, C1, D, it is moving from this particular position to another position A, B2, C2, D. Now you can see as the 4-bar mechanism is switches from one position to another, the input link it moves through an angle theta 12. In the output link it moves through an angle of phi 12. So the input link here it is the link AB. In the output link is obviously the link CD. So this is how you can choose some arbitrary points A and D on these two perpendicular bisectors, and you can see that this entire arrangement can be considered as a 4-bar mechanism in which this coupler link BC it is moving from one position, that is B1 C1 to B2 C2. Now, after having discussed the pole point concept in context to a 4-bar mechanism, let us talk about what is meant by a relative pole. So a relative pole is the pole of a moving link with respect to another moving link. So this is very easy to guess. Let's say we have one link, right? So in a 4-bar mechanism, let's say we have this coupler link BC. Obviously, this link it is moving relative to two another links. One is AB, the input link. Another is the link CD, the output link. Now if it is required to find out the pole point for this coupler link BC with respect to either AB or CD, then how can we achieve this? So let us try to understand this thing. Obtaining a relative pole point. So let us go back to our diagram again and let us go to each of the steps one by one. So we will again consider the 4-bar mechanism which is being shown in figure. Now we will assume that in this mechanism, this AB it rotates through theta 12, and corresponding to this rotation, the output link CD it rotates through phi 12 in the clockwise direction. Now what is required? Now it is required, this is very important statement. So this is our problem statement. It is required to obtain the pole point of link DC relative to AB. Now let us see how can we achieve this. So to obtain the relative pole point, here we are going to make an important assumption. Now what we are going to do? We are going to imagine that link AD is free to move and link AB is the fixed link. So initially if you remember, we were rotating this link AB through theta 12 in the clockwise direction. Now we are making an assumption that this link AB becomes fixed, right? And the adjacent link AD, it gets rotated through theta 12 from position AD1 to position AD2. Now again, as I mentioned, that the next step is to rotate AD1 to position AD2 through theta 12 in the anti-clockwise direction. Just remember, right, when we were making the assumption that this AB it gets rotated through theta 12, the direction of rotation was clockwise, but here we are making an assumption that this AD1 it is rotating in the anti-clockwise fashion. Now this is our second step. Now in the third step, we will take the centers B and D2, that means these two centers we are going to take, and then we are going to mark the location of this point C, right? So obviously we are just trying to observe that the points A, B, C, D, which new positions they are going to acquire. So A, D1 acquires the new position A, D2, then B, C1, the coupler link it acquires the position B, C2. So we already know the length of links, length of links AB and DC. So we will simply use these two lengths and we will simply draw two arcs, one with B as center, another with D2 as center, and we will locate this point C2. Now we can see the coupler link, it is simply moving from this location BC1 to BC2, while the link AD1 it gets rotated through theta 12 in the anti-clockwise fashion. Now we are simply going to draw the perpendicular bisectors of C1, C2 and D1, D2. So just remember, since we are interested to find out, right, the relative pole of output link DC with respect to AB. So what assumption we are making? We are simply for some time assuming that this link AB, it has to be a fixed link. Now here you can see we are going to draw the perpendicular bisectors of line C1 C2. That means this line which you can see here, C1 C2, and then another line D1 D2, right? So you can see there that this point D, it is simply moving in a circular arc. Similarly, point C, this is also moving in a circular arc, right? Now we will simply draw the perpendicular bisectors of C1 C2 and D1 D2. So this line, this blue line which you are seeing here, from here to here, this is representing the perpendicular bisector of C1 C2, and this blue line which you are seeing here, this is representing the perpendicular bisector of D1 D2. Now these two perpendicular bisectors, they are intersecting at point R12. So what is R12? R12 is simply the relative pole of link DC with respect to link AB. Now this is the approach to obtain the relative pole point. Till now we talked about how to obtain the pole point and relative pole point of different links in a mechanism. Now let us move ahead and let us see an alternative approach to obtain a relative pole point. So this approach, the alternative approach, it becomes important because it simplifies our task as we move further, or as the problem statement they become more and more complex. So again, let us see this diagram. However, I would suggest not to get scared of seeing this diagram. What we are going to do, we are going to see the steps one by one, and then it will be easier for you to understand this diagram. Now let us see what is our goal here, actually what we want to do. So what we are interested into, simply finding out the rotation of AD about D in a direction opposite to that of DC. That means somehow we are trying to find out this angle 2, right? So this angle 2, right? This is the rotation of AD. This is representing the rotation of AD in a anti-clockwise fashion about this point D, right? Now this angle 2, we are trying to correlate this angle 2 with theta 12 and phi 12. So let us see how can we do that. Now given the angle of rotation of output link DC with respect to input link AB, right? So obviously this angle we already know, right, that this angle will be simply equal to theta 12 minus phi 12. So obviously the input link AB, when we made the initial assumption, it is rotating through theta 12, and corresponding to this theta 12 rotation, the output link, it is rotating through phi 12. So obviously the relative rotation of output link DC with respect to AB, it will be simply equal to theta 12 minus phi 12. Now this rotation can be represented by this angle in the diagram. As you can see here that this link CD, it is the output link. Now this link CD, it is moving to this new position. Now you see here this C1 D1 is the initial position, right? And now this C1 D1, right, it switches to a new position C2 T2, right? So obviously the relative rotation between these two, it can be marked by this particular angle, that is theta 12 minus phi 12. Now let us see that angle turned by D1 C1. So if we try to figure out the angle which will be turned by D1 C1, so you can simply see here that this angle is nothing. This angle will be simply given by angle D1 R12 D2. So if you see that this D, if you simply consider a point D on the output link DC, you can easily see that as the link CD, it moves from C1 D1 to C2 D2 position. This point D, it moves from D1 to D2 in a circular fashion, and it gets rotated through this angle D1, R12 D2. So this will be that angle actually, right? Now we know that the relative rotation is also given by theta 12 minus phi 12. So this angle, it should be equal to this one. And now if we simply consider the perpendicular bisector which is shown by this line, and if we mark this angle as angle 1, right, that means this angle you can take it as A R12 then D1. So if this is our angle 1, so obviously since this blue line is the perpendicular bisector of this entire angle, that is D1 R12 D2, so this will also be angle 1, right. Now we can write down this angle as twice of angle 1. Now let us move ahead, let us further resolve this. So angle 1, it can be simply written down as angle 1 equal to minus 1 by 2. Then in the bracket we have phi 12 minus theta 12, right. So if you carefully observe this thing, that we have taken this as phi 12 minus theta 12 and we have taken this negative sign outside. This is just to represent that we are rotating the output link in a direction opposite to that of the DC. So this negative sign, it simply here. Now in the next step, we know that we will mark this angle as angle 4. If you check out this angle, so this angle 4, right, this angle 4 which you are seeing here, this is an exterior angle, right, to angle 1 and angle 2. So you have to simply observe this triangle A R12 D1. So this angle 4 is an exterior angle to these two angles, angle 1 and angle 2. So we can write down angle 4 is equal to angle 1 plus angle 2. Finally, angle 2 is equal to angle 4 minus angle 1. Now, if you observe here, this angle 2, it can be simply written down. This angle 4 is nothing. What is this angle 4? This is simply theta 12 divided by 2. So we know that this link AD, it is getting rotated from position A D1 to A D2. So this angle is nothing. This is simply theta 12 divided by 2. Now afterwards, after substituting this angle here, right, we can calculate this angle 2 is equal to phi 12 divided by 2. Now we know that this angle 3 is equal to angle 2, right. So what is this angle 3? Let us check it out. So you can see here, these two are vertically opposite angles, right. So this is our angle 3 which we have marked here. So angle 3 is equal to angle 2. So we can calculate angle 2 in terms of the output link, right, or rotation of output link phi 12, right. Similarly, we will define angle 3 which can again be expressed in terms of rotation of output link phi 12. So angle 2 is equal to angle 3, that is equal to phi 12 divided by 2. Now let us see, right. So if you remember, this was our objective actually. So we achieved our objective here. Now what is the purpose of doing that, right? How does it benefits us? So let us see in the next slide. So as I already mentioned, this is simply to easy our construction, right, to obtain the right mechanism for given motion constraint, right. Now how does it eases our construction? So let us see that. So now here you can see, again let us go step by step. So we will again assume AB as fixed link. So that was already our assumption, right. Now we are rotating AD through theta 12 by 2 in anti-clockwise sense about this point A. Now you can see again what I am going to do. I am going to obtain the relative pole point only. However, I am following an alternative approach and we did some calculations before. Now let us see how these calculations are useful. So what we are doing first, we are simply rotating this link AD about which point? About this point A through theta 12 by 2 in the anti-clockwise sense, right. So you can see here, so this link AD, it gets rotated to new position A D1 through what angle? Through angle theta 12 by 2. Now let us see what is the third step. Now in the third step, we will again pick up this link AD and we will rotate this link AD to a new position DA1 about this point D, right. Now the angle of rotation in this case, it will be phi 12 by 2, and again the sense of rotation will be anti-clockwise. So just remember, at one time we are rotating the link AD through theta 12 by 2 in anti-clockwise sense about this point A, and at another time we are again rotating the same link AD in an anti-clockwise sense through what angle? Through angle phi 12 by 2. So this angle is nothing, this is phi 12 by 2, right. Now after rotating right, we are going to simply mark the intersection of the line AD1 and the line DA1, right? So we are going to simply extend these lines AD1, right? So we are simply extending these lines. You can see here, then this line, this blue one, it is representing the extension of which line? Extension of line DA1, and both of these, they are intersecting at this point R12. So this R12 is our required relative pole point. So what actually happened? Let us see this, right? So to understand this, to comprehend this in a better manner, we are going to the previous slide. So let us see it once again, right? So if you check it out here in the previous slide, right, what was actually happening in the previous slide? We are simply locating this point C2, then we were drawing the perpendicular bisectors of this C1, C2, D1, D2, then finally after that we are going to mark the intersection, and we used to obtain the relative pole point R12. Now what actually happened here when we followed this alternative approach? So you can see here, in this case, our job has become much easier. Now we simply need to remember one thing, that we simply need to rotate this link AD, right, one time about point A, another time about point D, right, through different angles. In the first case, through theta 12 by 2 in the anti-clockwise sense, and in the latter case through phi 12 by 2 in the anti-clockwise sense. And then what we are going to then do that, then we are simply going to extend these lines AD1 and DA1 to mark the required relative pole point. So again, you can see our construction has become much simpler. And now again, as I mentioned right before, that when the mechanisms, they become much complex, right, and it is required to synthesize such kind of mechanisms, then these kind of constructions, they help us a lot. With this, I would like to conclude this session, and in the next session we will take the example of function generation, how to synthesize a mechanism for function generation using the relative pole point approach. Thank you.